Morning, dear students. I am Mrs.S.Sumathy. Today I am going to take this discussion on chemical bonds. You know, in your syllabus, that is grade 10 science textbooks, the chemical bonds are mentioned in unit 10, and normally, according to your syllabus, the chemical bonds are in two types. One is ionic bonds, the other one is covalent bonds. So in this session, I only focus on ionic bonds. So let's see what is ionic bonds and the other things. You see some letters A, C, T, R. So using these letters, what can we do? You know, in English alphabet, there are 26 letters. So in English language, using those letters, what do? You are making meaningful words. So we see that here, using that letters, I wrote some meaningful words. So like that, in the next slide you see. Here you see some chemical symbols of elements: calcium, hydrogen, chlorine, oxygen, neon and helium. So like in the case of letters, here too, using these elements you can make the chemical compounds or molecules. We will see here some compounds: calcium chloride, calcium hydride, calcium oxide, and some molecules: oxygen, hydrogen, hydrogen chloride. This is, we normally say, hydrochloric acid, and chlorine molecule, water molecule. And also you notice here these two elements, this is neon and helium. These are not participated in forming compounds or molecules. They are existing as a single atomic gas. Why is that? We will see in the here. You notice some elements. They are neon, helium and argon. These are, under normal condition, they do not form compounds. They are occurring as single atoms in nature, that is gaseous form. We call these gases as noble gases. Why is that? We will see in the Okay, the main question is, why do many elements form compounds, not noble gases? So for this question, the answer is discussed. So here we will see how to write the electronic configuration of some elements. Here neon and the argon are shown. You know, the atomic number of neon is 10 and the argon is 18. So according to that, the neon electronic configuration is 2,8 and the argon's electronic configuration is 2,8,8. So we will see how the electrons are distributed among the energy levels. So in the case of neon, here you see one red colored point, that is, we call the nucleus of neon. Around that there are two energy levels are shown here. There are so many energy levels, but electrons occupied energy levels in the neon is 2. The first is only has 2. The first energy level should have maximum of 2 electrons. So it has 2. and another one it is 8. So it's also having the same 8. So the neon, the two energy levels are fully occupied. So in the two energy level, the second energy level we call the valence cell. Valence cell. That means the last electron occupied orbital is the valence cell. So in the valence cell of neon, there are 8 electrons. You see, that means it obeys the octet rule. That is completely or fully filled valence cell. Like that in the argon, you see, there are 3 energy levels around the nucleus of argon. Its atomic number is 18, so that 18 electrons are of argon. So in the first energy level there are 2, and the second energy level there are 8, and the third energy level is also 8. So the valence cell of argon is the third energy level. So in the third energy level, it has the same 8. That means it obeys the octet rule. So that they are not necessary to participating in the reaction or losing or gaining the electron. That is not necessary. So they are not going the reaction, so that they are existing as single atomic gases, and also not participating in the reaction, so that we call they are inert. In other words, we say noble gases. You see the electronic configuration of sodium and chlorine. You know the atomic number of sodium is 11 and the chlorine is 17. So that its electronic configurations 281 for sodium and 287 for chlorine. And we will see how these electrons are distributed in each element in the energy level. So here sodium, the outermost energy level, that is the valence cell, the only one electron is there. Here the chlorine, there are 7 electrons. See the definition for valence cell. Valence cell is the outermost cell carrying electrons in an atom of an element. So we can explain this valence cell by using sodium atom. Here the sodium, the electron occupying energy levels are 3. So the last energy level is the third energy level. On that energy level, only one electron is there. So this is the valence cell of sodium. Like that, the chlorine, the third energy level is the valence cell. Here 7 electrons are there. And in the argon, here also the third energy level, here there are 8 electrons. And in the neon, the second energy level is the valence cell, it has 8 electrons. And also you notice in argon and neon, in the valence cell there are 8 electrons. That means they obey the octet rule. So they are stable. That means under normal condition they don't go to the reactions. So in the case of reactions they are inert. So we call these elements as noble gas. Consider the sodium and chlorine. The sodium, the outermost energy level is the third one. The third energy level, it contains only one electron. So sodium, to obey the octet rule, it has the chance to lose its one electron and becomes the monopositive sodium ion. The electronic configuration of sodium ion is similar to that of neon. So the sodium ion is stable one. Like that, the chlorine, the third energy level contains the 7 electrons. So it needs to get the to obey the octet rule only 1 electron. So it gains that 1 electron and becomes chloride ion. The chloride ion takes the electronic configuration of argon. So the sodium monopositive ion and the chloride ion, these two are now stable because these electronic configurations are similar to neon and argon respectively. So they don't go to the reaction. But you very carefully concentrate before forming the ions, the sodium and the chlorine, they are neutral atom. Now they become ions. Monopositive sodium ion from sodium and mononegative chloride ion from chlorine. But these ions are inert, that means don't go to the reaction, but they have opposite charges, so they are attracted to each other by very strong force that we call, that is electrostatic force. Then they make a bond. That bond is ionic bond. So this electrostatic force is the ionic bond. This bond we call another name electron. Now we will see the definition for ionic bond. The bonds formed due to the strong electrostatic attraction between the positive and the negative ions produced by the exchange of electrons among atoms are known as ionic bonds or electrovalent bonds. We will explain this definition by using sodium. You know, the sodium is the monopositive cation and the chloride is the mononegative anion. Between these ions, there is a very strong electrostatic attraction. Due to that attraction, the bond is formed. That bond we call ionic bond. So another name is electric. Here this diagram shows before combination and after the combination of sodium and chlorine atom as sodium positive ion and the chloride ion respectively. And also it illustrates the reorganization of electrons of an atom in the outermost shell during the formation of sodium chloride. So you carefully consider the sodium atom, its atomic number is 11. That means in the nucleus of sodium there are 11 protons. So you know the charge of a proton is positive 1. So there are 11 protons and 11 positive. So you already know the atom is neutral. So to be neutral, it should have 11 negative charges. So the electron, each electron has negative 1 charge. So the 11 electrons, 11 negative. So you add simply the 11 positive plus 11 negative, the result is 0. So that the sodium atom is neutral. Like that the chlorine, 17 protons plus 17 electrons, the charge is neutral. But in the combination, sodium loses 1 electron. So 1 electron is left from the sodium when it forms sodium positive ion. So the protons are in the nucleus, so 11 positive is there, and at the 10 negative, the result is monopositive. So we put the positive sign at the superscriptively sodium ion. Like that, here the chlorine, there are 17 protons and there are 80 electrons, because that chlorine atom gains one electron to obey its octet rule. So 17 positive and 18 negative, the result is -1. So we simply put in the chloride ion negative charge as the superscript. Here you see the ionic lattice of sodium chloride. You know the sodium chloride is an ionic compound. So it is not a simple molecule. It is in the form of ionic lattice. That means you should take care the sodium chloride is not like one sodium ion and one chloride ion. It is in the form of lattice. Here you see this lattice. The red balls or points are the sodium ions. The sodium ions are surrounded by 6 chloride ions. The green points or balls are the chloride ions. Then each chloride ions is again surrounded by 6 sodium plus ions. So like that this ionic lattice is built up. So it is a lattice, it is in the lattice form, not a simple. Some questions are given. You try these, and atomic number of each element is given, and the question is you write the electronic configuration of each ion, the positive cations and the negative anions. The answers for this question is in the following slide. See the answers. You can compare your written answers with these correct responses. I will explain the magnesium 2 positive and the oxide ion. Here the magnesium 2 positive, the electronic configuration is 2A, because you know the magnesium, its atomic number is 12. So the electronic configuration of magnesium is 2A2. To get the stable form, the magnesium loses 2 electrons. So it takes the electronic configuration of neon. So that is 2A. Like that here oxide ion, the atomic number of oxygen is 8. So its electronic configuration is 2,6. So to get the stable form of the electronic configuration of neon, it gains 2 electrons. So its electronic configuration is 2,8. Yes, you see some examples for ionic compounds. Sodium chloride is an ionic compound. The chemical formula is NaCl, like that the others. Here you notice in the ionic compound, in the ionic compound, positive ions and the negative ions. In all these cases, the positive ions and the negative ions are from one element. For example, in the case of magnesium sulfide, the positive ion, that is Mg2 plus, is from magnesium, one element, and the sulfide is an anion, that is from sulfur, one element. So this one you notice. See some cations and anions, and also some cations are from only one element. For example, calcium is from the calcium, one element. But you see the ammonium ion, NH4 plus is the ammonium ion. This is not from the one element. This is by nitrogen and hydrogen, the combination of more than one element. So in this case, we call this positive ammonium ion as the cationic radical. These are the ionic radicals. Like that you see here the oxide anion. This is from oxygen atom, one element. But here the carbonate ion, CO32 minus, and the sulfate ion, SO42 minus. These are not from one element. Here two elements are participating in forming that carbonate anion and the sulfate anion and the nitrate anion. This is we call anionic radical. So why we are studying this? You should clearly notice the ionic compounds. Ionic compounds can be formed by combining simple cation and the anion, that is from the one element. For example, sodium chloride and copper oxide or copper chloride, like that. But there is another possibility. These cationic and anionic radicals, they can combine together by a strong electrostatic force. They can to make ionic compounds. For example, ammonium carbonate and ammonium nitrate. And there is another possibility, the simple cation and this anionic radical can combine. There is copper sulfate, you know, and the copper carbonate. And also the cationic radical can combine with simple anion, chloride oxide. They form ionic compound. For example, ammonium chloride. Okay, here the copper sulfate and the calcium carbonate. Here the copper is the simple cation and the sulfate is the anionic radical. Here the ammonium chloride, ammonium is the cationic radical and the chloride is the simple anion. In the case of ammonium nitrate, the ammonium is the cationic radical, nitrate is the anionic radical. So you should notice, you should concentrate this type of possibility of ionic compound. This is an experimental setup to test whether the given solution conduct electricity or not. You know, there are two things conduct electricity. One is freely moving electrons. In the case of metals, for example, copper, silver, aluminum and iron, they conduct electricity because they have freely moving electrons. And other one is free moving ions. So in the case of ionic compounds, you know, the ions are present, but they are restricted to move because they are very tightly bound by a strong electrostatic force. So to make it movable, we should break that strong electrostatic bond. How can be done? By giving energy to break that bond, we can make it, these ions are in the movable form. So by fusing, we get the molten form of ionic compounds. In this molten form, the ions are movable. And we can dissolve these ionic compounds in a particular solvent. Mostly we use the water. Then they becomes aqueous form of ions. Then these ions are movable. Then these solution conduct electricity. Some characteristics of ionic compounds. You know, the ionic compounds, they have oppositely charged ions, that is positive and the negative ions. Then the most of the compounds are in a solid crystalline form at room temperature. You know why is that? Between the ions, the oppositely charged ions, there is a strong electrostatic force. So, due to that electrostatic force, these compounds are very tightly packed, so that they are mostly in a solid crystalline form at room temperature. This same reason they have high melting point and the boiling point. You know, in the melting, what we are doing by giving heat, we break that strong electrostatic force. So to break that strong electrostatic force, we should provide such much energy so that they have high melting point, like that high boiling point. And you have seen in the earlier slide, it conducts electricity in the fused or molten state or in the aqueous solution. And then most of the ionic compounds are soluble in water. Why is that? There is an interesting theory is there. You will learn in the next lesson the interaction between the molecules and the ion here. These ionic compounds are easily soluble in water. We will see that one. Some exercises are given. This is extracted from your textbook. These questions are very easy. Through my discussion, you got more knowledge on ionic bond and other things. So you can easily answer. I will only explain the fourth question. Here the question is, by using diagrams, how the compound calcium oxide is formed. It is very simple. You think about the formation of sodium chloride ionic compound. Here in calcium oxide, the cation is calcium 2 positive and the anion is O2 negative, that is oxide. So in the calcium, its atomic number is 20, the electronic configuration is 2882. So it loses the last valence shell electrons and gets the electronic configuration, stable electronic configuration of argon. And these losing electrons are gained by the oxygen and it becomes oxide ion, the anion, and it gets the stable electronic configuration of neon. These things you show by using diagrammatic representation and how this calcium oxide is formed. This is the answer for this question. Thanks for watching. Drop a like, leave a comment.